చెల్లె ఈ డోర్ దగ్గరికి రా. చెల్లెకి ఈ డోర్ దగ్గరికి రా. Good morning, my dear students. Today, previous days, I told about the various bus bar systems and all those things I told. So today I'll discuss you more on. Are you getting my voice? Are you getting my voice? Okay, thank you. Thank you very much. Uh, Today I'll discuss, actually few people are going to be joined. Only 10 people are joined. So I'll start the class right now. So yesterday I told about the substation point of view and what are the parameters. What are the parameters we have for the we have what are the various factors you have to see. Today you will discuss. I'll discuss about that. I'll discuss about that. So before going to the substation topic, I want to give. Is my screen shared? Is my screen is shared? Okay, done. So before going to the substation point of view, so where the distribution, or actually the distribution system is starts from the transmission end. Okay, so transmission end point of view, we have primary distribution system, after the secondary distribution system. I told you about the primary distribution system and secondary distribution system. Okay, so for that, before going to the, I told about the radial feeder, loop type feeder, ring main type of feeder, and mesh type of feeder. Those are practical type of feeders I told. Okay, the main consideration, the main design considerations of the feeder will decide the substation. Substation. So in a feeder is a one level of the substation. Okay, through the feeder only, through the feeder only, in between the substation to the feeder, in between the substation to the distributor, you have a feeder conductor. Okay, all of you remind this. Okay, so most of the cases I told you, distributor network is most complicated and most reliable, and even in the very rare condition, in the very rare condition, it is more economical. Okay, so automatically we will go for the loop type of thing as well as radial type of thing. So which one I will go for? Radial network type of thing, like ringman type of thing, you will get like this. Okay, so this is about the loop type I have, this is about the radial type I have. Okay, these cross symbols are nothing but, see here, I have a bus bar connection, two ways I have the bus bar connection, two ways I have the bus bar connection. Through the any feeder, any loss is any fault is happening, automatically you will get a continuous power supply from the another bus bar. Within a fraction of seconds you will get the this particular thing. Okay, so what is that dot and what is that cross symbol, what is that lines? Lines are nothing but the feeders, and this is about the distributors lines, and these dots are nothing but the transformer with the connected loads. Okay, the dots are nothing but the dots are nothing but the transformer with the fuse transformer as well as the connected loads. Those are load connections, load pointing connect loads and load pointing connections. Okay, these cross symbols are nothing but the circuit breakers for the both the ends. If fault, whenever in between the two circuit breakers I have a fault, okay, which location is nearer, automatically we, by the using of one circuit breaker, nearest circuit breaker, we will cut down the power to that particular bus. We will go for the another busway, we will have a another busway connection. So through the another bus connection we will get the power. Okay, so this is about the ring main type of thing. So here you have a substation. Here you have a substation. All are connected with the substation. At the bus bar, at the LV side, see here, LV out, LV input is substation. See here, substation input, substation input, substation input. Three substation inputs are there for the three buses, bus 1, bus 2, bus 3. Okay, so one substation is linked with the other substation, other substation is linked with the other substation. What I told, see, at the load level, at the load level, at the low voltage level, which are connected like a radial type. Okay, at the substation level, at the substation level, which are connected like a radial loop, radial main type of thing. Okay, ring main type of thing, you can connect that. At the substation, at the secondary distribution transformer base, those are connected in a parallel. Here seriously connected means when one power is off, automatically you will not see, these are all are connected in a parallel individual load side. But see, automatically there is a slight change in the connection. So this is when you see the radial type, see here, this is the typical diagram of the primary distribution system and secondary distribution system from the substation. So this is there in a one level of one bus bar is having, one bus bar is having this particular circuit. Okay, another bus bar is also having this particular circuit. Those are interconnected, those are interconnected. So whenever fault is happening, automatically, whenever fault is happening, automatically you can isolate that fault, you will get a power supply from the other network. So this the way you will get the continuity power of the system. Okay, so this is about the feeder and how we will go for the feeder collection. So power flow between any points is usually split among the several paths, and if a failure occurs in instantly and automatically root itself root itself. This is seldom used because it proves very expensive. Okay, so whenever you have the radial ring main type of thing, okay, ring main type of thing, automatically, which is very expensive when compared to the radial type and loop type. So why we are going for the feeder? See, after the substation rating, we are having the feeder voltage rating and feeder loading also. Depending on the feeder voltage rating, depending on the feeder level, feeder loading level, we will have the distribution to the in each and every distributor. Through the distributor we will get the power. Okay, the factors, the next topic of the thing is factors affecting the feeder voltage level. Okay, so feeder voltage level is depends on the feeder length, feeder loading, how many feeders are connected, how many distribution substations are connected, and its rating through that particular feeder, and number of customers affected if any failures are appear. Okay, the dead time, at the dead time, at the dead time, he need this particular data, and how many primary distribution lines are there. Depending on that also you can decide the feeder voltage level, all of you remind. Okay, and the feeder voltage level is decided by the feeder voltage level is decided by the uh, system maintenance also. And always remember, feeder voltage is decided by the voltage square factor. Okay, voltage square factor and voltage levels also. Okay, so what is voltage square factor is nothing but, okay, all of you remind this, all of you remind this, new, it is a voltage square factor is nothing but new voltage level square to the old voltage level square, line to neutral, new voltage square to the, it is a ratio between the squaring of the line to neutral new voltage level to the line to neutral old voltage level square. Okay, length of the particular ratios. Okay, length ratio I have, where here length ratio is nothing but length ratio and voltage ratio. Length ratio is nothing but new length to the old length. So whenever I want to load a feeder, I want to load a particular feeder depending on the system substation level. So depending on the substation level, you want to increase, means you want to increase means already length is there around the 33 kilometers. So I'll give a brief explanation on this. See, your class is there. Imagine your class is there. Your class is fit for 72 students. Why means each and every row is consisting of six benches. Each bench is having a highly accommodate three people. 3 into 6, 18. 18 into 4 rows are there. 4 rows are there. 18 into 4, 72 people are there. Okay, I want to, already I have 83 people. So I want to accommodate 83 people. So I want to increase the level of my substation. Okay, I want to increase the level of that particular class limit. So how I need to increase? Depending on the length, depending on the loading, depending on the loading of the people. So automatically here, this voltage square factor is also decides by the length ratio as well as load ratio. Load ratio is nothing but new feeder loading into divided by old feeder loading. Okay, length ratio is nothing but new length to the old length. I have 33, 4 by 10 I have, your classroom is 6 by 12, 6 by 12, I want to increase the level. Okay, 6 by 12 I have, I need to increase the level to the 8 by 16. So like that I have the how much length I need. Depending on your loading, that will gives the voltage square factor, that will give the feeder loading of the thing. All of you remind this. Okay, and we have abcd parameters. Abcd parameters are there. Okay, transmission line whose are called as a transmission line parameters. Okay, sending end voltage is equal to avr plus bir. Sending end current is equal to CVR plus DIR. Okay. See here, in general, sending end voltage don't have any phase angle, but receiving end voltage is having some angle. Why means you have the phase lags and phase leads are there. So depending on that, you can have the feeder loading also. Okay, depending on the ABCD parameters also, depending on the application of the ABCD parameters also, you can determine the primary feeder loading. Okay, so how means, see, whatever we are using the power is, whatever we are using the power is active power. Active power is nothing but, active power is nothing but PR is equal to, in terms of power factor and the receiving end voltage and receiving end current, is equal to, when I am assuming receiving end voltage is VR, V suffix R, receiving end current is I suffix R. Okay, so I suffix R, power factor is phi R I have. So PR, P suffix R is equal to, this is about the active power, is equal to V suffix R into I suffix R into cos phi R. Okay, I need current, current at the receiving end. Ultimately, current we will calculate. I suffix R is equal to P suffix R divided by V suffix R into cos by R I'll get. So this IR is depends on the sending end voltage and sending end current. That's why we need to have a relationship. We need the relationship between the sending end voltage and receiving end voltages. So sending end voltages and receiving end voltages are having a relationship between the, we have the relationship along with the sending end current and receiving end currents by the formulas of transmission line parameters. Okay, sending end voltage is equal to AVR plus VIR. Sending end current is equal to CVR plus DIR. Is it correct? So this is the way you can have a, when you do the calculation process, this is the formula you will get. This is the way you can have a feeder loading and feeder voltage loading you have. Okay, depending on the levels, depending on the incremental, continuous incremental of the loading, you need to load the feeder. Okay, so already it is feeder is nothing but a conductor level. See, automatically you have increased the voltage, sending end voltage level means feeder is not having the capability to have that to have the to have that particular to withstand that particular level. So you want to load before before giving the power supply, before giving the, you want to decide how much level you need to go for the feeder. So depending on the future load growth also, you need to go for, you need to see the feeder load. All of you remind this. Okay, is it okay for you? You can start, you can give me your opinions. I'll go for the next topic. Hello, can I explain more, one more, tell me. Okay, thank you. So secondary distribution side, distribution system. So secondary distribution system is one that feeds the electrical energy to the consumer depending on the area, depending on the number of consumers and their load requirement. It can be either a HV distribution like 11 kV, 6.6 kV, or 3.3 kV systems. The secondary distribution system should take into the account both short range as well as long range problems, possible expansion, and future needs and demands. So depending on this particular load ranges, you need to fix the, you need to know the, you need to know about that particular things. Okay, you need to know about that particular things. So this will gives you the, and secondary voltage levels are standard in most of the countries. In Asian and European countries, we will have 400 to 415 for the three phase. For the single phase, 230 to 240. Okay, the choice of the voltage is depends on the load. If you have the, if you have higher amount of load, you can connect that to the 400 to the 415 for the three phase. Okay, and the other factor that decides the voltage is the appliance rating. Okay, voltage is the appliance rating. Sometimes secondary networks are interconnected with common secondary mains called as secondary banking. This is also remember. Okay. Sometimes some secondary networks are interconnected between the two secondary connected. Already I have secondary distribution system. I have another secondary connected distribution system. So I need, there is a two interconnection. So because of two interconnections, automatically those things are like a bank. When one side power is not there, automatically you have a power sending from the other bank. So this is nothing but a secondary banking. This is also called a secondary banking. This network may be fed from more than one or more primary distribution network. Okay, this is what the next level. Okay, next level of the, already I told about the substation location, how we will have the substation location. Okay, the selection of the site, the selection of the location is nothing but a site. Okay, site for the substation is of prime important in the prime planning of the distribution system. Is it correct? Yes. Okay, is it correct? Yes. The most economical position of the substation site is at the center of gravity, at the center of gravity of the loads to be supplied. Okay, so I have a huge amount of loads. Huge amount of loads are connected like a loop type or radial type, but but depending on the gravity, center of gravity of the loads, we can locate a substation. More amount of loads are required there, required power there, you can go for the location of the substation nearer to that. Okay, nearer to that, the voltage levels, voltage regulation considerations, the transmission cost, substation cost, and cost of the primary feeder mains, and the distributions and transformers dictates the location of the substation. Okay, these are all the main factors you need to have. However, to select an ideal transformer purpose, the following routes are the following rules should be considered. Okay, so I told you, location of the substation as much as feasible close to the load center. I told you just now, load center to its service areas, so that the additional of load times, the distance from the substation is minimum. Okay, and so whenever, if the center point you known, if the center point you known means automatically, if any distance to cover the all the loads are equal. Okay, if more amount of load requires, automatically you can give more amount of power also. Okay, and see, normally it is not possible, it is not possible at the load center level. Already existing this system is there means it is not possible, you need to expand that. Already I told substation expansion point of view. Okay, it is not possible as the load center will be in the heart of the city, where the cost of land is high, cost point of view. As far as industrial and commercial substations are located within the consumer premises. Okay, so whenever I don't have the that particular capacity, you can have the what, you can have industrial and commercial substations over there. you have a separate feeder line to that particular feeder. That separate line, it is called as a express feeder. Express feeder. Okay, uniform feeder is nothing but a radial type. Express feeder is nothing but a separate connection. Okay, separate connection you will have for that. Okay, and its selection must be provision for proper access for the incoming subtransmission lines and outgoing primary feeders. Okay, it should help to minimize the number of customers affected by the service outages. See, which so I'll go for the chart bus. So I need 100% power. Okay, oldest square factor. So mana oldest square factor is also is defined as it is a ratio between the it is a ratio between the it is a ratio between the line to neutral voltage, new voltage new voltage squaring of the new voltage line to neutral voltage to the squaring of the line to neutral voltage of old voltage new to the old. Okay, it is also defined as the it is the multiplication of the length ratio to the load ratio. Okay, load ratio is nothing but new feeder loading to the old feeder loading, and length ratio is nothing but a new length to the old length. See, feeder loading feeder loading is decided by the oldest square factor. Oldest square factor is defined as it is a ratio between it is the multiplication of the load ratio as well as length ratio. Load ratio is nothing but new feeder loading to the old feeder loading. New feeder loading is nothing but line to neutral, squaring of the line to neutral new voltage level to the line to neutral old voltage level square. Okay, this is about the load ratio. And length ratio is nothing but new length to the old length. Okay, is it okay? Is it okay, Sumana? Okay, thank you. So I want to go for a best location for the substation. What your views for the substation? Tell me. You have seen, you have listened a few factors. Tell me your views. Near to load center. Thank you, Vidya. Near to load center. Very nice. Next, I need more amount of comments. Only one. I got it. Okay. Vidya is correct. Where you will go, you need to see the whether the substation location is nearer to load center. That's why it is when you want to establish a when you want to construct a new substation means they will go for a layout of that particular land. Okay, it is like a grassy area. You have separate methods to find where is the center point. Okay, like xy coordinate method or a perpendicular bisector method you have. Okay, perpendicular bisector method you have for to identify the load center. Okay, so Whenever you want to locate a substation purpose, near to the load center is the first criteria. Near to the load center is the first criteria you need to see. And where already load center is center of the city means you can go for the more amount of substations, like a if it is connected to the industries or commercial things, automatically you may move for the industrial or commercial type of substation by the separate feeders. Okay, by the separate feeders and separate amount of sub transmission through the separate amount of sub transmission lines. And this location of substation as much as feasible close to the load center, that is the distance between the loads and substation is minimum. Okay, the distance between the loads and the substation is minimum. So for our Warangal city we have 32 substations. We have 32 substations, but load scarcity is there. Load scarcity is there, and availability land is also there. Very nice, Vijaya. Once again, I want to appreciate you. So proper voltage regulation. When the length is there, length is more, automatically drop is also there. Because of the drop, voltage regulation may also increases or decreases. So proper voltage regulation can be obtained. Proper voltage can be obtained or has to be made. Okay, and it should provide the location of the substation is it should provide proper access for the incoming sub transmission lines and outgoing primary feeders. Incoming sub transmission lines and outgoing primary feeders, and also allows the future growth. Whenever you want to locate a substation means within a some span of within a short compact type of thing I have arranged means which is not suitable for me. Okay, it is suitable for the future. You need to see the future growth purpose. You need to see the sub transmission lines are coming or not. Where some additionally I need to go for the another line. I need to go for another line means your substation is having that capacity also. You need to look for that. You need to look for that thing here. You need to look for that thing here. Okay, and it should the substation, the location of the substation should provide enough space for the expansion of the substation in future. Okay, expansion, if loads are continuously increasing means you need to expand your substation. Okay, that is also required. Okay, the located substation for construction of substation, the locations selected for the construction of the substation should not be opposed by the land use regulation, local ordinance, and neighbors. I told you in the first three clauses also. Okay, the location of the substation should satisfy the okay load center I have. Okay, load center I have at the load center I have mud near to the mud. So mud located area is not fit for the substation. Okay, see, right now I have a greatest example for that. See, recently we have some few amount of cyclones are happened. Okay, a number of 2 to 3 substations are in the water. You have seen, you have really seen. At the Shivanagar I have one Shivanagar backside and Gopalpuram substation, 2 substations I have seen. Practically those substations are in the water. Okay, because of cyclones. Why means they have some huge amount of loading. Because of the XY coordinate they have located that particular substation location. But those land use regulations are not fit for that. Okay, those land use regulations are not fit for that because of the load load requirement they have established there. Okay, but futurely we may not affect that particular thing also. Why means within a fraction of seconds that substation may shut down, and we will have a power to the another thing, another type of another from the another substation, or the located area will get the already was got the power. Okay, and if any service discontinuity is there, the additional point is, if any service area discontinuity is there in the substation, then the number of customers affected should be minimum. Okay, this is also remember. This is also remember. Okay, all of you remind this. Next topic is rating of the distribution substation. Okay, the rating of the distribution substation depends upon the load density of a service area. Okay, so see here, already substation I have it. It should follow the land use regulations. It should follow the land availability. It should be more available at the load centers. So all these considerations are there, and it is following, and I have located a substation. After that, you need to rate a substation. That rating is depends on the load density of the service area. Okay, so each and every substation is classified into the four feeder pattern. In general, in practically, we have four feeder pattern and six feeder pattern. Okay, four feederly I have the distributed. Four feederly means individually each and every service area is going to get equally, means like a square shape it is formed. Square shape it is formed. Four feeder pattern or square shaped feeder you can have. And like six feeder pattern, when you go for the six feeder pattern, you can have a for the six feeder pattern, you can have another name. You can have another name of six feeder pattern is nothing but hexagonal type of feeder. Individually you have special advantages and special amount of things. You have some calculation also. Okay, that rating of the distribution system is depends, excuse me, excuse me. మాట్లాడదాం రా. నువ్వు రా, కిరణ్ తీసుకొని రా. నిన్న కిరణ్ కూడా మాట్లాడింది. సో the rating of the distribution substation depends on the load density of the service area. With the increment of increasing of the load density, the additional load requirement can be met by either the service area of the given distribution substation maintaining the constant and increasing of its rating, or installing new, so where or installing new distribution substation, and thereby maintaining the capacity of the given distribution substation constant. Okay, so automatically, sorry, okay, is it okay? Is it okay? So the distribution system changes with the type of the distribution planning, that is long term planning or short term planning. Okay, for short term planning, the load density is constant. Okay, for short term planning, load density is constant. Load density is nothing but per square meter how many loads are connected, you need to follow. Okay, so for short term planning means for the 10 years I need to build a substation for this, is nothing but load density is constant. For the long term planning, load density is in increasing position. Okay, by the using of the short term planning and long term planning, most of the distribution companies will plan about the long term planning. Long term planning. Practically, the load density is involved for long term planning is at increasing stage. Is at increasing stage. In order to meet the increasing load density, the additional load capacity requirements of a system are by holding the service area of a given substation constant and increasing its capacity, and it is helpful to employ all of you remind. Okay, by holding the service area of a by holding the service area of a given substation constant and increase its capacity. Okay, already service area is fixed, but increasing of this capacity. Okay, increasing of the capacity, why in the way of your classroom is fixed, but per bench I have I have adjusted that, instead of 3 I have adjusted that 4. Okay, I can go for the 72 people, more than 72 people, like that I have. And second one is developing a new substation and thereby holding the rating of the given substation is constant. Okay, holding the substation given rating is constant to develop a new substation. It is very helpful to employ the geogrammatical figures to represent the represent the represent the station service areas. Okay, station service areas. So it simplifies greatly the comparison of alternative plans, which may require different sizes of the distribution substation, and different number of primary feeders and different primary feeder voltages. Okay, primary feeder voltages. So uh, for that, for that, so I'll use the paint for to explain this how I am going for the substation modeling and all those things. I have a like zigzag type of thing. I'm using the black color. This is a location. I think this is a map I have. Okay, for this particular map, I want to locate a center. I want to locate a center. Okay, so for that, which method you are going for? Okay, there are two methods: perpendicular bisector method, another one is perpendicular bisector method, or perpendicular bisector method, or xy coordinate method. Okay, so first one, perpendicular bisector method, is nothing but, okay, first of all, at the four sides I have the four sides are there. Okay, east, west, north, south are there, na? So from the center, I need to find the center. So first of all, I need to draw each side a straight line. Like I am going for to take a straight line. See here at one side I am taking a straight line. Straight line. And at the other side I am taking a straight line which is perpendicularly bisected to the particular thing, and at the other side I am taking another one. At the other side I am taking a perpendicularly bisector one. The four sides I have. Okay, I am leaving the remaining things. After that, you for this particular thing, okay, you want to locate the center. Okay, nearest to this particular point. This is about the substation location point when the area is like this. Okay, when the area is like this, you want to go for this particular perpendicularly bisector method. Okay, or xy coordinate method is nothing but okay, xy coordinate method is nothing but I have selected a area. For that particular area, you have load density, you have load requirement also. Okay, already existing load density I have. You need to go for the higher amount of loads also. So depending on that, weights you will have. So that particular weight wise, you can decide the location of a substation. Okay, this is the way you can fix the location. Okay, you can fix the location. Is it okay for you? Hello? Okay. Okay. So next one is, I'm moving for the next topic. So how I am going for the xy coordinate method is nothing but I'm taking different loads, M1, M2, M3, M4. These are all are the loads in the town and for the various industrial centers. And x1, x2, x3, x4, x5, x3s are the n amount of distances corresponding to the reference point. I have taken one reference point. Okay, that reference point, center of gravity I need to find. Center of gravity is equal to, okay, depending on the loads into individual distance. Okay, m1 x1 plus m2 x2 plus m3 x3 so on mn xn divided by m1 plus m2 plus so on mn. This is about the center of gravity finding. Similarly, y coordinate method is nothing but location of the substation with the point here point wise, one point, second point, third point, their loads assumption here point wise, first point, second point, third point, like that. I have for this location of the substation, the volume indicator material required for the to feed various loads for the same voltage drop is minimum. Okay, so whenever you are moving to locate or to rate the distribution substation, it should be it should be follow the one important point is voltage drop or voltage regulation should be minimum at any low center of gravity point. Okay, is it okay? If you have any doubt, I'll let you know. Let me know also, and you will also get some answers. Please give your comments or give your things. Hello. Srinivas sir, are you there?
Yes, sir.
Sir, are you taking the attendance?
Yes, sir.
Manual wise.
I am not taking manually, sir. I am just downloaded.
Just wait. I need to go for that. Why means just wait. First of all, we need to take sir. Yesterday, Satish sir posted me the hello. What is it? Right. I have the attendance also. Satish sir posted that. Hello, individual members, you can give your phone, your roll number. We will note that. Actually, here your roll number was not fixed there. Here. Hello, Srinivas sir.
Sir, tell me, sir.
You collect this చార్ట్ విండో కూడా వస్తుంది కదా మనకు. శ్రీనివాస్ సార్, మై
Sir,
ల్యాప్టాప్ ఈస్ గోయింగ్ టు షట్ డౌన్. నేను ఒక ప్లేస్ నుంచి ఒక ప్లేస్కి వెళ్తున్నాను, కొంచెం చూసుకోండి ఇది. ఓకే.
okay, sir. I will collect.
Thank you, students. You give me your roll number, and I am closing the right now class. By Monday, we will meet you again. Stay home, stay safe. Hope you are all are good. శ్రీనివాస్ సార్, నేను క్లోజ్ చేస్తే ఇది పోతుందా?
Unta, sir.
ఓకే. ఉంటుందా పోతుందా అని?
Unta, sir.
ఉంటుందా? ఓకే ఓకే బాయ్.
Yes, everyone is completed. Your attendance, postal attendance.